Okay, so I said I would do a little demonstration here. First thing, you guys just wrote down your verbal descriptions of the table. More than likely, it was table A is a long, thin rectangle. Table B is more of a squat, almost square rectangle. Okay, so this is called qualitative data. It's fine. It's good. We always log it. It's always good to have as much data as possible. This isn't really the one that we're concerned with in science. We're concerned with quantitative data. What's its length? What's its mass? What's its velocity? What's its volume? Things you can measure. You must measure everything, because that's how you know anything, is to measure it. All right, so let's just do it. Now, we could do length of the table by we could look at the angle of the corners. We're going to do it that way. We're just going to do it the old-fashioned way is what we're going to do. I'm just going to trace it, which is essentially the same as measuring. It doesn't have to be perfect, but just for our purposes here. So I'm going to trace this tabletop. Ooh, whoopsie. It's going to be a little ziggle there. So, all right, once again, for our purposes. Okay, so now it's been traced. Now what I'm going to do is I'm going to lock it in place here. I don't think you'll be able to see me do this, but I'm going to lock it in place so that it cannot be sized. The size can't change, okay? So I've just done that. Okay, so now it's locked, which means I can move it. Whoopsie. Go back. Which means I can move this guy around, but I can't make it bigger or smaller. It is locked, okay? All right, so there's table A, long, skinny rectangle. Let's move this guy over here, spin it, and see that well, that's interesting, isn't it? It's the same tabletop, isn't it? Let's move it back. Okay, fits here. Let's move it here. Okay, fits here. So everyone that wrote a description saying that A is a long, thin rectangle and B is a short, squat rectangle, almost a square, everybody who wrote that you're wrong. Okay, that's the way it is. If you want to write a description, if you were going to say a description between the two tabletops, you'd basically say they are the same. Okay? What's going on here is happening in your brain. It's not happening on the canvas. It's happening in the part of your brain that is working with the data your eyes are giving it, and that's a problem. This is why you measure everything in science, because it doesn't matter what you thought you saw or what you thought you tasted or what you thought you felt, or none of that matters. The only thing that matters is quantitative data. That's how you know the truth. That's how you know what is real and what is not real. Just do it for you. Ooh, look at that. We're going to get those guys moving together. That's exciting. Yeah, see, there you go. They don't look the same. I've been doing this for 17 years with this image, and my brain will never, ever see them as the same. It just can't. Because of the way the legs are and the way it's drawn. It's an illusion, but the illusion's in your brain. And that's why people believe crazy things, because they think that there's two different tabletops here. There are not. There is one size tabletop. Come on, you. There we go. There you go. Okay, lesson number 1. Don't trust what you heard, saw, felt. Measure it. That's how you get to the truth.